Welcome to the demo for the Fisher Precast Suite, where we'll explore the functionality of this powerful tool designed to streamline precast engineering processes. Today, we're going to guide you through the key modules and features of the Precast Vault application, providing insights on how to effectively use the software to manage your projects. When you log in to the application with your credentials, you are going to see 6 different modules. In the future, we're going to add more. The first module we'll cover is the Precast Vault ACI 350 and ACI 318. The second module is the Precast Vault LRFD. The third module is the Manhole Design LRFD. The fourth module is the Light Pole Base. The fifth module is the Wing Wall LRFD 9th edition. And the sixth module is the Anchor Wall. Within each module, you'll find both a View Data and View App button. The View Data button takes you to your saved files, which are all stored in the cloud. The View App button allows you to start your selected module. Simply click View App to begin. This suite continues to evolve with new modules, so we encourage you to share your feedback. Since this is a live precast suite, we ensure that when design codes are updated, our application is updated accordingly. Our clients will always have access to the latest and most advanced design modules. This will take you to a new screen where you can input your project data. Start by entering the project information. Be sure to provide a project name, as this is how your file will be saved and retrieved later. For this demo, we'll name the project Project 2. If your vault has an identification number, enter the structure ID and the date it was created. Next, choose your design code from the drop-down menu. The options are AASHTO LRFD or ACI. For this example, we'll select AASHTO. You'll also notice ACI 350 listed, which is a feature we plan to add in the future. If you want to email the report to yourself, make sure to fill in the information for the precaster and include the user's email address. In the geometry section, you'll need to input the internal dimensions: length, width, and height. Remember, the length refers to the longer dimension. For this example, we'll use 8 feet by 4 feet. The height field is currently inactive, as it depends on the configuration you'll select later, which we'll revisit shortly. Next, enter the wall thickness, which we'll set at 8 inches for this example. We'll also use 8 inches for both the base and top thicknesses. The earth cover refers to the depth of soil above the vault. It can range from 0 to 1.5 feet. Next, enter the water depth, which is the distance from the ground surface to the water level. For this demo, set it to 2 feet. At the bottom right, you'll find fields for height configuration. Enter the measurements as 0 feet, 4 feet, and 4 feet. Keep in mind, with a wall thickness of 8 inches in this example, the sum of the last 2 fields, 4 feet plus 4 feet, equals the wall thickness. Now, move on to configuring the structure. Select Separate Slab for the top, add a single riser, and choose Monobottom for the base. As you make these selections, the graphic on the right will update to visually represent the components coming together. Once the structure configuration is complete, the left panel will automatically display the additional tabs needed for the design process. Now, let's move on to the technical data section. Start by entering the concrete strength, which for this demo will be set at 5 KSI. Next, input the steel yield strength at 60 KSI. Then, update the soil unit weight to 120 PCF. Now, scroll down to the vehicle load section. Select Y for yes or N for no, depending on whether vehicle loads are applicable. If vehicles are present, choose the AASHTO HL93 load, which includes a design wheel load of 16 kips and a design tandem of 12.5 kips. However, if you're dealing with pedestrian traffic, select No for the vehicle load, which will adjust the load to 300 PSF. Next, navigate to the Top Slab Design tab on the left panel. Here, you'll see the data you previously entered. Take this opportunity to review and confirm that everything is correct. If any changes are needed, you can return to the Data section to make adjustments. For the reinforcement design, it will ask you if you want to reinforce it one-way or two-way. This answer will depend on whether you have many openings or if the reinforcing can only go one way. Otherwise, leave it as no. We will adjust the bar covers to 2 inches. Next, the system will ask if you need single or double layers of reinforcement. For instance, according to NYS DOT standards, if the top slab thickness is 8 inches, double layers of reinforcement are required, meaning you'll need 2 layers in your design. As shown on the plan to the right, you now have those 2 layers visible. Once the design is complete, the system will display whether your component passes or fails, as indicated on the plan. In this demo, you'll notice the top slab design status shows no, meaning the design has failed. To troubleshoot, scroll down to identify the issues that need attention. For the items that do not need to be addressed, you will see an OK next to it. For the items that do need attention, you will see a no next to it. For this demo, you will see a no by both the flexure check and cracking check. I am going to bump your reinforcements. You will now see that the NO text has changed to OK. If you scroll back up to the bottom of the plan, you will see OK next to the top slab design status text. You can now move on with your design. If you are wondering what the locations are as noted on this screen, you can view the plan and it will show you. Next, navigate to the Riser Design section by selecting the Riser Design button on the left panel. You'll be prompted to enter the riser height. If your design includes multiple risers, you'll start by designing the first riser and the base. For this demo, we have a single riser with a height of 4 feet, so go ahead and enter that value. Next, you'll be asked to select whether you need single or double layers of reinforcement. For this demo, I'll select N because we need 2 layers of reinforcement. Set the bar cover to 1.5. You'll then need to specify the location of the horizontal bars, whether they're positioned inside or outside. Once entered, the plan will update, and you'll see that the riser design status is marked as OK, indicating that the design is correct, and we can proceed. At location 7, I see that the current bar size is number 5 at 8 inches spacing. To make the design a bit lighter, I'll adjust the spacing to 12 inches for this demo. This adjustment works, so I'll also test the bar size by switching to number 4. Even with the 12-inch spacing, the number 4 bars perform well, and this is a design I'm satisfied with. Just be sure to confirm that the design status is still marked as OK on the plan, so you know it's good to move forward. Next, move to the monobottom data, which refers to the walls of the monobottom section. You'll see the previously entered information here. I'll set the bar cover to 1.5. In the Reinforcement Design section, select whether you need a single layer of reinforcement. For this demo, I'll select No. Next, you'll encounter the Cantilever Design option. If there is a large opening, as shown in the plan, the reinforcement bands do not continue, meaning the design relies on the bars from the bottom slab, which act as a cantilever. Select Yes if this applies to your design. Select Yes for the cantilever design if applicable. Otherwise, you can leave it as is. After entering the bar sizes and positions, review the design status. Although the system indicates the design is acceptable, I feel it's a bit heavy for this demo, so I'll adjust the spacing to 12 inches and change the bar size to number 5. The design still shows as OK. To make it even lighter, I'll add another 12-inch spacing adjustment. Once again, I'm checking the plan to confirm that the monobottom design status remains. OK. Now, let's move on to the bottom slab design. The steps here are quite similar to the previous ones. I'll select a single layer of reinforcement and adjust both bar sizes to number 4. After making these changes, I'll check to ensure that the bottom slab design status shows OK. Next, let's perform the buoyancy check. Start by entering the required safety factor from the contract drawings you're working with. In this case, the safety factor is 1.1. Now, let's move on to the wall openings. For this demo, I have a 6-inch opening, 2 of them, one on each wall and the top slab. Additionally, I have a rectangular opening, approximately 24 by 24 inches, and a hatch. Next, scroll down to check the safety factor, which in this case is 1.5. Since it's higher than the required 1.1, we're good to proceed. If the safety factor had been too low, you could address this by considering a soil wedge, adding an extension to the bottom slab. For example, by adding a 6-inch extension, the safety factor increases. Now, let's move on to generating the report. The first step is to save your work, which should only take a few seconds. Once you see the success message, you're all set. You can then click the link to download and review the PDF version of your report. We recommend saving this PDF for your records. In the report, you'll find comprehensive details, including project information, inputs, configuration, and the design status, along with a table and sketch. The report will include specifics about the riser, bottom slab, and base slab. Additionally, the buoyancy check will indicate if you meet the safety factor, such as showing 2.16, which is greater than 1, confirming you are in the safe zone. Finally, the material takeoff section lists the required cubic yards of concrete and the total weight of steel reinforcement. Now, return to your project, where you'll have the option to email the report directly to Fisher for prompt review and stamping by a licensed engineer. Once the precast manufacturer finalizes the structure sale, the design can be quickly transmitted for review. For added assurance, detailed calculations sealed by a professional engineer, available in certain states, can be provided upon request. If you prefer not to save the report, you can also email it to yourself using the Email Report to User button. When you return to the home page of the application, select View Data and you can see your project. You can see, edit, view, or copy it. That wraps up our demo for the Fisher Precast Suite. As you've seen, this tool offers a comprehensive approach to designing and analyzing precast structures efficiently. If you have any questions or would like further assistance with your project, don't hesitate to reach out.